researchers and stakeholders across the state. I'll talk a little bit more about the network in my talk here in just a minute, but I was raised in Girdwood, Alaska, about 45 minutes from Anchorage, and I'm now raising my two 8 and 10-year-old boys here in Anchorage.
Great, thank you. And Jacqueline, would you like to introduce yourself, please?
Hi, everyone. I'm Jacqueline Ramsay. Been here at the Alutiiq Pride Marine Institute in Seward. I am a shellfish biologist, and I'm the OR lab lead, the Ocean Acidification Research Lab here at Alutiiq Pride. That's about it.
Great, thank you. And last but certainly not least, Claudine, would you like to introduce yourself?
Sure. Hi, everyone. I'm Claudine Hauri. I live and work on the traditional homelands of the Lower Dene here in Fairbanks on the Trothiata campus. I moved here from Switzerland about 12 years ago, and I'm raising my 3 little kids here with my husband. And I'm mainly interested in how climate change impacts the chemistry of the water around Alaska. And so that's partially ocean acidification, but then also nutrients and so on. And in my little group here at the International Arctic Research Center, we use observations, but then also models to understand what's going on, and then also how that affects living marine resources that are important for our people in Alaska. Thanks.
Great, thank you. And with that, I would like to go ahead and jump into our panel presentations. So Darcy, would you like to, you should be able to share your screen now if you would like to get us started out.
Great, can you see my screen?
Looks good, thank you.
Excellent. I guess before I even start into ocean acidification, I wanted to first say that the Alutiiq Pride Marine Institute and the Chugach Regional Resources Commission have been a huge partner in addressing ocean acidification, sampling, generating interest and curiosity and data. So we'll talk a little bit more about those specifics, but I just want to start off by saying thank you for the efforts from probably some of the individuals on this call and from your communities and regions for your involvement also in harmful algal blooms, and that you are setting a national example. I'm going to go kind of start off with a refresher on the topic of ocean acidification that then Claudine and Jacqueline will build off. So we'll start at the 30,000 foot level of what is ocean acidification. And it's often referred to as the other carbon dioxide problem because it has the same root cause as climate change. So as we emit carbon through human activities, most of it ends up staying in the atmosphere, but about 1/3 of it gets absorbed by the ocean. The ocean's acting like a big carbon sink. And we track this on a global scale. And there's a graph here from NOAA that's data from Mauna Loa on Hawaii. And you see the red line, that's the upward trend of carbon emissions in red that probably looks familiar. And then in green is the concentration of carbon dioxide in the water. And you can see this is pretty well correlated. The water is absorbing atmospheric carbon dioxide. And then you can see the blue line, which is pH, and this is inversely correlated, is oppositely correlated. The more carbon dioxide that gets absorbed by the water, the lower the pH and the more acidic the water becomes. And since the Industrial Revolution, globally, our seawater has become about 30% more acidic. And this trend is expected to continue based on current emissions trajectories. This next map usually makes Alaskans particularly attentive because we see our part of the world lighted up here. The color that we're looking at is aragonite saturation, which is a proxy for corrosiveness. And you can see that the pools are more corrosive. And this is naturally because our water is cold, and cold water can absorb more carbon dioxide. So Alaska is already a hotspot for this. And that means the extra amount of carbon dioxide that we're adding to the atmosphere can make a big difference. This image here is pre-industrial. I'm going to click, and now we'll see aragonite saturation state projected to 2100, and we're looking at 175% increase based on this model. So we know that this is an issue that Alaska is going to be faced with, that Alaska is already faced with, and that we need to address. So why do we care about this? We care because organisms are sensitive to a drop in pH, and actually so are humans. Our blood pH acidity level is very tightly regulated, and if it moves beyond, like, I think a couple hundredths, humans can stop breathing, other systems shut down. So there's different types of impacts that we're learning about how marine species respond to changes in acidity, and one is related to shell building. So an increase in carbon dioxide in the seawater reduces calcium carbonate, which are like building blocks. And the image on the top shows a pteropod, which is a free-swimming sea snail. And you can see in this image, it's been exposed to higher acidity water over time, high acidity or higher than normal acidity water over time. And you can see the degradation in the shell. And this is a particularly susceptible species. It also provides particularly good imagery, so it gets photographed a lot. And researchers are already seeing this type of pteropod shell degradation in the global ocean. And we have just started looking into this in Alaska, and I've seen some examples in the Bering and the Gulf. We're seeing a range of sensitivities across species based on lab studies. And there's a lot of different ways to do lab studies. It depends on what life stage of a species you're looking at, the length of exposure, the level of acidity, and results are showing some winners and losers with our early knowledge based on these studies, and we'll talk more about some of those specifics in a minute. I also wanted to touch on impacts to fish. So it's not just shell builders that are impacted by changes in acidity. And impacts to fish can happen in a couple of different ways. Some are direct impacts. So say you're a juvenile fish, it might affect your growth or the energy that you need to put out to do the normal things that you do as a happy, healthy fish. There can be food chain impacts. So if ocean acidification is affecting your food source, say you eat pteropods and there's fewer pteropods, there can be impacts there. There are also sensory impacts. One example is to the olfactory sense, the ability to smell. So if you can't smell your predator, it might be harder to hide or get away. And then there's cumulative impacts. So we have to remember that ocean acidification isn't happening alone. It's happening in an environment that's also warming and experiencing a lot of other changes, many related to climate change. So if you're a fish and you are hungry because your food source is struggling, and you're hot because of warming, and you're dealing with slightly higher acidity levels, there's concerns about ultimately causing population level impacts. So we know this is going to be a problem. And here are some of the questions that we're hearing from Alaskans across the state. Is it happening now? What species might be affected? Will this impact subsistence? How might this affect my long-term plans? And when do we actually need to worry about this? And we don't have concrete answers to all of these questions and all the questions, additional questions that we're hearing, but we're getting closer. And one of the big goals is to try to structure research and partnerships across Alaska to start figuring out actionable information to answer these questions. I wanted to touch a little bit on the Alaska Ocean Acidification Network, and this was established in 2016, realizing that we could really benefit from a coordinated effort in Alaska. And the mission is to to work with researchers and stakeholders to expand our understanding of ocean acidification, both processes and consequences, and also look into adaptation and mitigation opportunities. So the network is made up of researchers and fishermen and shellfish growers and tribal members and community members and policymakers, all working together, trying to help researchers collaborate and engage and communicate with Alaskans and sharing information. And fortunately, Alaskans are really collaborative, and there is a big interest from the research community in sharing information and working together. And CRRC has been a big part of this, and Claudine and UIF colleagues are part of this, and Jacqueline, and it's exciting to see how much energy and effort there is in working together. I'm going to touch briefly on monitoring. and how we do it in Alaska. Just with this one slide, we could go into this much deeper at a different time, but we're talking about a global problem, but it has local impacts because of local drivers that influence chemistry. So conditions across the state aren't uniform. And also, further complicating things, there's not like a simple pH test that's accurate enough to pick up the changes. So a suite of variables is needed to be collected. And there's a large natural variability across our state that makes it kind of tricky to tease out the trend. It's especially tricky in a state that's the size of ours. The coastline is big, it's sometimes covered by ice, so it takes a collective effort of agencies and institutions and community efforts and kind of a spectrum of gadgets and gizmos and vehicles, some of which are seen here, and some of which are in the Chugach region, and Claudine and Jacqueline will be telling us a bit more about some of these. I have a couple bullets from the 30,000-foot view of what we're learning. Again, establishing a baseline and trends takes time because of this very large natural variability. So what we know so far is initial, and we will need to continue augmenting it with more data. But some things that we do know is that water is unfavorable to species in some places during certain times of year right now. Conditions are different from one place to another based on natural influences. Fall and winter tend to be more corrosive. These are due to cycles of phytoplankton blooms and mixing. Bottom water is typically worse. And there's a few other factors listed there too that we could get more into during the Q&A part. So species response, based on what we know about future conditions, what can we start learning about how species might respond? And there's 17 Alaska species that have been studied in the lab in some way for their response to ocean acidification. And there's a poster on the right. There's a link that I think can go in the chat to an electronic copy of this, and we can also send you a hard copy. But it shows how these different species fared in the lab with respect to calcification, growth, reproduction, and survival. And you'll see that most of these are down arrows. Also important to mention that the lab is often a worst case scenario since the organism is trapped in the lab and doesn't have adaptation options that might be open to them elsewhere. I don't think I have time to talk individually about some of these species, but if you go to the Alaska Ocean Acidification Network website, there are pages for different species under species impacts. So what we're one analogy that often comes up with this is headlights on a car. We are working to stop the car, but while we're doing that, how can we best gather the information that we need to try to prepare and adapt? And also realizing again that this is not happening in a vacuum. There's other major changes going on in the ecosystem, particularly with regard to temperature. And then I wanted to just note some of the resources that are currently available about ocean acidification in Alaska. There's been a lot of efforts to work together to make science available, to translate it into understandable ways, and to continue dialogue with communities around the state. So there are some brochures on response of different species, some state of the science brochures. There's a monthly listserv that goes out that has latest information, findings, interviews with researchers or community samplers. Always a good news corner, which is important. There's a podcast that focuses on solutions. And we've had some discussion series. We're gearing up for another discussion series for early 2024. I think there's a link that will go in the chat here too, where you can help provide input into what you would like to hear about or talk about during a discussion series. So I think with that, I'll pass it off to Jacqueline, who's going to talk about community efforts within the Chugach region and what we're learning there.
Okay. Go ahead and share my screen. Hi, everyone. Thank you for being here, and thanks to the organizers, Gwen and Aaron, for inviting me. If you hear a little pinging, my computer is every now and then it just wants to shut my mouse off, and that's the ping that you might be hearing. I wanted to talk to you today specifically about the change in the Chugach region, we have a lot of different samples that we process, but for this talk, I'm going to specify our Chugach region and talk about our community monitoring. So this slide is a map of our communities, the 7 villages of the Chugach region: Chiniga, Eyak, Nanwalek, Port Graham, Seward, Tutitlik, and Valdez. Our goals for this program are to develop tribal capacity to monitor for baseline data to see what is going on in their communities environment and to be able to engage in relevant issues that affect them in the future. And as Darcy mentioned, and thank you, Darcy, for that great lead in, it makes my job a little easier. What is increasing CO2 in our atmosphere doing to our oceans, and especially the nearshore environment? What does this mean for our subsistence lifestyle? And hopefully these are some of the questions that we can start to answer with this baseline data that we're collecting. The chemistry, as Darcy mentioned, excess CO2 mixing with seawater causes an excess of hydrogen ions, which depress the pH and can also bind with carbonate minerals, that making them less available for shell-forming organisms. Our program at Alutiiq Pride with the OR Lab was started back in 2015 with our first task of making a field sampling pack kit that was easy enough to use and take out into the field. So here we have a durable shipping container, a 6-pack, there's actually 2 6-packs of beer bottles that are easily reused, easy to cap, and make them shelf stable with fixative. And here's a picture of a 6-pack about to be analyzed. This is a picture of the wet bench in the lab where the beer bottle will be placed on the wet bench and analyzed. This is a shot of the OR Lab Berkolator, which is the CO2 analyzer that we utilize. Down here we have 3 CO2 standards, gas standards, that help to calibrate the machine. Up here we have liquid standards that also come into play, calibrating the machine for the liquid state of CO2, which we call TCO2, and then the back down to the gas cylinders for the PCO2, the gas stage of CO2. This is a picture of one of our samplers that you saw earlier in Darcy's slides. And we hold sampler training every year, sometimes more than once a year, depending on our sampler schedules. And this is a picture of our samplers from Nanwalek, Port Graham, and Eyak. One of our first sampler training here at the OR Lab. We also we utilize IGAP funding, program funding for the villages within the CERT, and that's how we pay for training and travel to the training. We hope that this baseline data could potentially help us fill data gaps for species management. So as we move into the data, we'll talk about these 4 sites. I'm actually going to be narrowing it down to 4 sites for this talk. Chuniga, Port Graham, Tutitlic, and Valdez. And the table at the top will show you how the length of the data set and a little bit of the notes about the data set. The most complete data set that we can see here is Chuniga, and this is PCO2 over time from January 22 to March of 23. What else can I talk about on this slide? We do triplicates. We ask that our samplers take a triplicate sample once a month so that we can compute error at least once a month. And that's what you can see down here. This is a triplicate sample with an error bar. We like to have it a little tighter than that. Little issues with fixative can occur and headspace. But I think that's about all I can say about this slide at this point. Except to point out that there are certain times of the year when we might see higher PCO2 signals at different sites. This might be occurring from some sort of a driver freshwater input. More data, more analysis needs to be done on all of these sites. So we talked to, Darcy mentioned aragonite saturation. Aragonite is a calcium carbonate mineral that's a readily available substrate for shell-forming larvae in optimum times. So on the right side of the axis here, we have the aragonite saturation state, which is this green line, and I've got a circle around 1. We think that aragonite saturation, it depends on the species as to where the sweet spot is for aragonite saturation, but we think that below 1 it can be corrosive to shell-forming species, some shell-forming species. That's why I have that circled. I also have a pH of 7.8 circled. Again, this is, not exactly going to be the what every species tolerance is going to be, but I've kind of narrowed those down to see what when a site drops below that. For Chuniga, it looks like the aragonite saturation is pretty low in the summer, fall, late summer and early fall. I wanted to point out also that these graphs represent samples taken by village environmental specialists that have been working very, very diligently trying to get these samples. We do have some gaps in the data due to COVID and other issues, staffing at sites and things of that nature. Some sites may also be weakly buffered, which means that CO2 input could perturb these data points quite a bit if it's a weakly buffered system. With more baseline data and fewer data gaps, we could perhaps tease that information out and make more informed decisions about what's happening at each individual site. Seasonal trends are hard to pick out with such short data gaps, so I'm not really going to talk about that here. We saw the Keeling curve in one of Darcy's slides here, and I wanted to point that out, as well as the different drivers of marine CO2 weather, just to kind of put this in your mind that different sites are going to be different in their variability, depending on what drivers are associated with that site. And you can see coastal upwelling here, and coastal upwelling isn't, excuse me, really an issue at any of our sites, excuse me, but it could be like in South Central, Southeast, excuse me. So so defining our next steps, what should be in a community report? How do we report to our communities and make it meaningful? We'd like to, the OR Lab would like to collaborate with experts for data interpretation and identify local community drivers, like the last slide that I showed you, as each site would be different. With this data, we should be able to detect local extremes, hopefully the timing and duration of those extremes. And we hope to identify refugia for shellfish so that we can establish clam gardens in those sites that wish to have clam gardens. With the OR Lab, we should be able to assess vulnerability to local subsistence species, and I'm going to have to cut this short. And thank you all. Thank you to my lab assistants, Cora McKean and Jacob Cohen, who helped a great deal with this. Thank you.
Thanks so much, Jacqueline, and I hope you can get some water. That sounded painful. But that was great information, and really interesting to see the data sets. So now we've kind of learned a bit about what ocean acidification is, talked a little bit about what's going on in our region, and I'd like to hand it over to Claudine to talk a little bit about kind of modeling to talk about modeling and projections for ocean acidification and kind of what we might be able to do with that. So without further ado, go ahead, Claudine.
Sure, now I have to find the unmute button. Yeah, I'm going to talk a little bit about our modeling activities that we have been doing for the last 10 years and, you know, what we can do into the future, how we could use the model that we have established to look at future conditions and how these simulations into the future may be useful for different people, but also for the communities, the local communities that are dependent on living marine resources. And so to start off with, I just wanted to again emphasize that we're on, or that I'm working on the Trathiada campus, which is on the Lower Tanana lands. And it's a beautiful place to be at. And I just switched. Usually I show a really nice fall picture, but since we have a lot of snow, I figured I need to switch that picture over. So Darcy and Jacqueline gave a really good introduction on kind of, you know, how the chemistry in the water really changes because of different drivers. And I just want to point this picture out here. In the Gulf of Alaska, we have many different physical, biological, and also chemical drivers that can change your CO2 in the water, but also the pH and the aragonite saturation state. Like, for example, poor glacial streams and tidewater glaciers can really have a big impact on your aragonite saturation state along the coast. So it really decreases it. So it dilutes basically your chemistry in there. It decreases the pH as well. But then, for example, here you can see this phytoplankton bloom, which you can also see in this satellite picture here. What happens is you have little phytoplankton, little algae that then take up the CO2 and put oxygen. So they take up the carbon dioxide, but they put oxygen into the water. So again, you have this natural driver that then increases the pH and decreases the CO2. And then Jacqueline was also talking about you know, circulation, like for example, upwelling along the US West Coast, down in California has a really big impact by bringing CO2 onto the water, onto the shelf. But here in the Gulf of Alaska, we have more of a downwelling regime, which is good. So generally when there's strong downwelling, CO2 is kind of like being averted, not going onto the shelf. But then if that downwelling stops or relaxes, you have more deep water coming onto the shelf, and that then brings higher CO2 water onto the shelf. And I guess I'm showing this figure mainly because all of these processes that are happening within the circulation, but then also biology, we can describe with mathematical equations. And this is basically how a model is set up. It's a bunch of mathematical descriptions, equations that describe circulation. Some of the equations like Navier-Stokes equations that describe how the water flows. This is well beyond what I do because somebody else wrote that model, but I am a person who uses these models. So it's a bunch of code that can then be run and that can then give you, for example, like here, we're looking at salinity across the Gulf of Alaska. So because of all these equations that describe the biology, chemistry, and physics, it can then give you a picture of how salinity, for example, here, surface salinity, looked like in the past. And the way that you do this is you force the model with past conditions along the boundaries that we have from data sets, but also from the satellites. And, you know, we use wind data, we use air temperature data, we use CO2 data from the atmosphere that were collected. And so by forcing the model, we can then kind of like, we try to reconstruct the past. And we have done that from 1980 through 2022. And so the next step would then to be to look at how well the model simulates or represents the past. Like for example, here you're looking at salinity. It's a cross section that goes off of Seward. And here on the left-hand side, you can look at observations that have been taken. This is Addie, my graduate student, who goes on all the LTR cruises that leave Seward in spring and summer and fall, and she collects similar samples like Jackie, and salinity, of course, is being collected too. And basically what we're doing with the model, we then compare how well the model here on this side, salinity, just as an example, is represented by the observations. And that kind of like tells us how well the model simulates what we actually see. And so we learn about, you know, where can we trust the model and where do we really need to take the model output with a grain of salt. And you can see, for example, here, that's near shore. You can see how the model is able to represent the salinity or the freshwater input, but it's not as fresh as the model, as the observations, for example. Or here you can see deeper water coming in, so higher salinity water, and the observations shows that too, but the model is a little bit off on it's a little bit too, the salinity is a little bit too high. And this is just an example, and we have been doing this now for about 10 years, like really evaluating our model, making sure we are understanding what's going on. We have improved it over the last years, and with the observations. And here is a a different plot, but then again, using modeling output and observations, you're looking at the time series from 1993 until 2023. And the line, this is model output from a station on the shelf, in the middle of the shelf. And this is model output again, but this is a station right at the shelf break. And both of these are taken right at the bottom, right on the shelf. So it's not surface, but it's on the shelf. And then here, these are the observations that Addie has been collecting over the last few years. And you can see the model is doing a pretty decent job. I mean, the model will never be 100% correct, but it's good enough to really think about, you know, how can we use the model to better understand ocean acidification, the trend over the last 10, 20, 30, 50 years, but then also to better understand the drivers that Jackie was talking about before. How can we use the model to understand why we see high or low CO2 throughout the year, or why is one year much higher than another year? And in this example, for example, we used in one of our studies, we used the model output to get a better understanding of the trend. Like, for example, on the shelf break, we saw a trend of 0.001 pH decrease per year. That's probably not going to tell you much, but it's important to just kind of look at how different regions across the world, how different the pH rate of change is. And what we also have worked is, what we have also done this year is use the model to better understand extreme conditions on the shelf. Like, for example, the Gulf of Alaska, they had the Gulf of Alaska ecosystem was exposed to very strong marine heat waves in 2015, 2016, and then again in 2019. And this is model output, and it basically shows here on the x-axis, it shows the time, and then on the y-axis, it shows the spatial coverage of these marine heat waves. And you can see that the model was able to simulate those heat waves that the Gulf of Alaska ecosystem experienced during these years in 2015-16, and then again in 2019 or 2018-19. And what we did now was we used the model to understand, one, whether other ocean conditions were also at extreme levels. And so we looked at high acidity, low oxygen, and heat compound events. So that means basically an event where not just the heat was extreme, but also the oxygen and the acidity. And in the 2019 marine heat wave, that was the first time when all of these components were at extreme levels. And now we are able to go back and use the model on one hand to understand better what drove these extreme events, but then also kind of like use the model to look at extreme events across that entire time series and maybe compare it to observations that the community members made in terms of organisms. So we could then compare chemical extreme events that we see here in this model with observations that people have made over the past years. And so, again, we have been working on this model for a long time already, and we are feeling more and more confident that we understand the model itself, so its flaws and opportunities better. And so we are feeling comfortable to take the next step of one, ocean forecasting for the Gulf of Alaska. So that will be near-term forecasting, but we also just submitted a proposal to do climate projections, which would mean we will go further than just a few months in advance. We would go up to 50 years or 100 years to also think about climate adaptation strategies. And in the next few slides, I'm going to talk about a proposal that we just submitted with the Chugach Regional Resource Commission, with a few people here on this call, also with Darcy from the network, and with NOAA as well. And in one of the proposals we submitted, we are going to try to do near-term forecasting. And one important point within this collaboration is really to make sure that we're promoting equity among the forecast users, just because modeling can be kind of like a scary thing, right? Because NOAA uses models to inform their fisheries management. And so we want to make sure that the model is not going to be used against subsistence users, but that we can use the model to really uplift everyone's voices to make sure that we are really protecting the food security, but then also the way of life of the coastal communities in the Gulf of Alaska. And so we have several activities planned if this gets funded, but we want to make sure that we can translate the relationship between oceanic conditions that we're seeing in the model, in the simulation that we ran back to the past, but then also into the future, and try to translate this with the security of subsistence resources for the tribal communities. And we're hoping to be able to do this with knowledge exchanges, where we will share the model capabilities. So one thing we're trying to do as well is develop a harmful algal bloom forecast. And we could then use the observations that are being collected in the different communities to evaluate the model, but then also give back by maybe being able to use the model to give some information about when would be a good time to harvest during the summer. We would also like to use the knowledge exchanges to co-develop model products, because just because I think something is useful doesn't mean that it's actually useful to the community. So I think having good discussions about, one, what the model can do, and then two, how we could turn the model output into products that are actually useful, I think that can be very beneficial. And then also NOAA, the NOAA person we're working with, Bridget Ferris, she is also very interested in taking part in these knowledge exchanges. And so she could give us some information about, how the model could be used for management responses, and then also kind of like listen to the exchange, how this would potentially impact the community. So really kind of like try to build on relationship building and come up with different solutions for the big issue we're facing with food security and commercial fisheries as well. And then at the same time, of course, NOAA is very interested in a forecast, in short-term or long-term forecasts to inform the North Pacific Fisheries Management Council, and then also NOAA's ecosystem status report. And Bridget also said, who is from NOAA, who is editing the ecosystem status report, she would also be very interested to braid in Indigenous knowledge into the ecosystem status report, because we all know that only with different knowledge systems we're going to be able to, work with these big climate and ocean acidification issues that we are facing in the future. And so, I'm really interested in talking to all of you about this, and hopefully the two proposals that we submitted will be funded so we can have some good community discussions and collaboration. And I just want to acknowledge, of course, the things that I'm doing here. I'm not doing by myself. I want to acknowledge Rita Irving and Remy Paché and Abby, and then Ryan as well, our undergraduate student who has been going on cruises. Thank you so much.
Oh, I think you're on mute, Erin.
I am still on mute. Sorry about that. I was saying thank you so much, Claudine. That was very, very interesting. And And I'm really excited about this potential project as well. I think I really do hope these get funded and that we can continue these dialogues about ocean acidification and protecting food security in our region. With that, I did want to open it up to, I know I have several questions for our panelists, but I want to make sure that we get to audience questions first. So I'd like to open up to questions. And Gwen, did we have any in the chat at all so far? No, okay. Okay. I will please feel free to, raise your hand, go off mute, or put any questions that you might have in the chat.
Erin, I have a quick question.
Yeah, go ahead.
Hi, it was very interesting. I'm just wondering how much I know this is not the Chugach region, but I'm wondering, I saw Nome, I think is one of the places that some of the information is being picked up. What kind of, are you working with any groups out in the Norton Bay, Norton Sound area, Seward Peninsula area to do some test monitoring out there for ocean acidification?
I can fill in a little bit there. We do have a number of sites up in the that are in the Chugach region. We have a site in Nome, and we're going to be analyzing that data a little bit separately. The salinity and temperature have so much to do with this data that some of our samples from Nome are such low salinity that I need some expertise to kind of take a look at it and tell me what the data is telling us. And the way that we fix samples with mercuric chloride it can affect low salinity samples. So, but we do have sites up in Nome. And Barrow. We were sampling in Kotzebue. I think that stopped though. So yeah, and we also have a site out at King Cove that has been sampling for a while. So hopefully I'll be able to get that data out at some point in time.
I can just add a little bit to that too, for other work that's going on in the Bering Sea area. I just put a note in the chat or a link to regional conditions around the state. There's a page on the Ocean Acidification Network website that has a page for each region that gives a general overview and tries to synthesize some of the information that's been collected by various monitoring efforts. And in the Bering Sea, there's modeling efforts underway by Darren Pilcher. He's a researcher at University of Washington that's looking at both hindcast and starting to do some forecasts. We have a lot less monitoring data in that region, but there's been some new partnerships trying to put ocean water sampling, water sample efforts connected to some of the fishery surveys out in the Bering Sea so that we can, at the same time, while we look and see what fish are out there that particular year and how many, we can also see what those water conditions are like. And I know there's interest in more of those partnerships where we can use cost-effective ways to try to get out there in a place that's typically very expensive to sample. There's also a mooring out in the Bering Sea called M2, and I can direct your, it looks like I'm going to just stick another link in the chat it's got moored sensors across Alaska that shows some other locations where moored sensors are collecting data.
Okay, because I was curious, and I don't want to take up too much time, but I work with Gwen. I'm the Associate Director of the Model Forest Policy Program, and we're working with the Norton Bay Watershed Council, but I'm also currently working with the Native Village of Elam, and I've also worked with Native Village of Unalakleet. And so we're looking at, I mean, it just, because we're also, one of the projects we're working on is looking at the feasibility, or that the Watershed Council is looking at, is possibly a national marine sanctuary for Norton Bay, Norton Sound. But this whole thing with the ocean acidification is very interesting. I mean, I can see potentially a similar, maybe a possible monitoring system that would be working with some of those villages out there. And I could see that it might be something that the Watershed Council, or just curious of the partnerships out there. So that was why I was asking, and I may follow up with you afterwards on it.
That sounds great.
Thank you.
We have a question, I think it's from Cora, asking what resolution will the model have for nearshore, coast and coastal sites?
Yeah, that's a very good question, Cora. The model is at a 4-kilometer resolution, so there's no way that we can actually really resolve the very near shore. What the model can do is really inform us about how you know, bigger oceanic patterns that may be driven by climate as well can affect the near shore. And that was one of the struggles we had too when writing the proposal. You know, how can we make what we have available to really inform kind of like nearshore harvesting and so on. And this is why I think going into the direction of like thinking about how we could forecast harmful algal blooms, but then also kind of like, how the environment in the nearshore is driven by kind of these larger oceanic and climatic patterns. I think that can be very helpful too, to understand some of the patterns that Jacqueline sees in her data as well. So I think there's a lot that we can connect, but we will never be able to tell you the pH at one of the beaches within a meter resolution. That's just not possible unless we would start making a very high resolution model. And even then we don't have enough observations like we do for weather forecasting in order to be able to make such a precise forecast, which weather forecasts are not always great either, obviously, but much better than what we could do.
Great.
Thank you, Claudine. Just note that there are a couple of new links that Darcy put in the chat for locating sampling sites, moored sensors and other sampling sites. So more information there is available.
I had a question for Jacqueline, actually, and maybe the rest of the panel could also expand on it. But I was really curious in the PCO2 graphs that you showed. Valdez seemed almost a magnitude like higher than the other communities. It was, recording measurements in like the 3000s versus the other ones were in the hundreds. And then I also noticed in the other or the next graph you had that it seems the pH and the aragonite saturation levels were much lower. So I was just kind of curious if you have thoughts or clues, like what's going on? Is that statistically significant there in Valdez, and kind of what's happening there?
Yeah, Valdez is an interesting situation. Thanks for the question. Very low salinity, lots of glacier input. If you notice the map that I showed earlier, and I can share my screen again if need be, but they're surrounded by glaciers. It's a very, very low salinity area. And what I can say about that data is going to be temperature and salinity. It's very much driven by that. And beyond that, we have previous site information on Valdez, but again, we really do need to analyze that deeper. But for the most part, I think it's temperature and salinity that's driving the Valdez issue to be so much different than the other data from the other sites.
Interesting. Kind of goes back to the point that I think everybody made on the panel too, that there's so many different factors that are impacting what's going on, and how vulnerable a lot of the resources are to climate change.
Yes, very much so.
Any other questions? I think we have time for one more, if there's any. If there is one more. Okay, well, thank you. Thank you so much to our panelists. That was really great. And we will be sharing this on our YouTube channel. I know several people expressed that they really wanted to be here, but just there's too much going on at the same time. So yeah, thank you for all of this great information. And yes, moving on to our next half hour, I wanted to take this opportunity to share a little bit or to share a draft of some of the things of our regional adaptation plan. And let me go ahead and share the screen. I have, I apologize for this. This is the wordiest PowerPoint presentation I have ever created, and I'm a little bit embarrassed by how many words there are on it. So please bear with me, but I wanted to take this opportunity to share this and get feedback to give you guys a little bit of background. So this tribal adaptation plan has come about after many years of working towards it. In 2014, CERC's board first identified climate change as a topic of concern and asked staff to start looking into what we could do to address climate change and how it was affecting our region and what we could do to address it. In 2016 to 2017, we had several workshops that really focused on and identified traditional foods as a primary concern about how climate would be impacting both access to the foods as well as those resources themselves and the environment and ecosystems upon which they depend. Over 2019 to 2022, we conducted a vulnerability assessment in our region, specifically looking at traditional foods. And this image that I have up here is the snapshot of the results from that. We asked people around the region, both through some in-person meetings before COVID hit, and then over an internet survey and through conversations and phone calls and interviews after COVID hit. Two questions. One, what do you think is the risk to different foods from climate change? And how much would changes to the distribution or the abundance of those resources impact you and your livelihood? So with that second question, we asked people to to use one as kind of there'd be no noticeable impact, all the way up to 10 as the and 10 being a life-changing impact, like needing to get a new job or relocate to a different community. So that's kind of the snapshot of these results. And then based off of that, we took that and we worked with the climate cohort that I mentioned at the beginning of this call, a group of community members from around the region who are interested in climate change, to develop this adaptation plan that we are currently, that I'm currently sharing with you. So let's see. So we started our adaptation planning process by defining community resilience. And the definition that we came up with is that it is building a healthy, thriving community that people want to stay in, and where people have access to affordable, safe housing, good paying jobs, a connection to culture, and access to healthy subsistence foods. So this definition and this plan were developed over 3 workshops with the climate cohort. We also worked with the Model Forest Policy Program and with Gwen on a kind of education and a peer education program that took place over a year with bi-monthly webinars that we really learned from each other and took a deep dive into some of the priority subjects that came up. So the plan contains 6 primary resilience strategies, and so far there's 97 actions to support those strategies. The focuses of those actions are really kind of on a lot of different places. They're actions that can be undertaken at the regional level. There's actions that support food webs and ecosystems. actions that protect and enhance people's ability to harvest traditional foods and also pass that knowledge on to the next generation, and also actions that monitor the health of ecosystems and those resources. So the strategies or goals, those 6 that I mentioned are 1, engaging with policymakers and resource managers to address institutional barriers to resilience, increasing regional climate literacy, and applying multiple perspectives to understanding how climate change is impacting our region. 3 was increasing local capacity to mitigate and respond to climate impacts. 4 is developing programs to manage and protect traditional foods. And 5 is building our regional understanding of how climate change is impacting human and community health and mitigating those impacts. And then 6 is more of a guideline that we periodically review and update this plan to make sure that it reflects current needs and priorities. And I will say that, so before I jump into some of the details on this plan, we are looking for feedback on it. I am not quite finished with it. I feel like it's complete enough to present it, but I'm still doing a little bit of tweaking up on it. I will be sending it out to our communities for review, and I invite review and feedback over the months of December and January. I do have a feedback form that Gwen can share in the chat. And that also will, it's got a place that you can put your email address if you would like me to email you a copy of the draft. And I anticipate that that will be mailed out before the end of the month. My goal is next week. I'm just not quite there yet. But without further ado, here's what we have so far. So going back to that first strategy, engaging with policymakers and resource managers to address institutional barriers to resilience, some of the actions identified, including protecting and enhancing tribal sovereignty by advocating for enhanced co-management agreements, utilizing existing mechanisms such as tribal conservation districts to leverage funding and political influence, and supporting federal recognition for Chugach Native Tribe and Valdez Native Tribe. Also advocating for hunting and fishing regulatory changes that reflect new climate realities. CIRC has had some success doing this so far. In Port Graham, the moose hunting season was noticeably getting cut off, or it was getting noticeably harder for people in Port Graham and Namwalik to harvest moose because of seasonal changes. And so we were able to work with them and petition the Board of Fish, or sorry, the Board of Game. Moose is not a fish. Petition the Board of Game to change the hunting period so that it works better with kind of some of the new seasons that people are, or those shifting seasons people are experiencing. And we also wanted to develop tools to analyze and communicate the implications of climate projections on fish and wildlife species. And then finally, engaging with lawmakers to enhance tribal resilience funding and improve federal and state programs that are offered to tribes. So that second strategy is to increase regional climate literacy. So a couple of actions that we identified under this strategy are preparing local workforces for future careers in natural resource management and climate-friendly technologies. For example, working with fishermen to build climate-ready fishing fleets, providing scholarships and training to students, entering new and emerging green technology fields, and also really building up and developing natural resource management and leadership pipelines so that people that are born and raised in this region and want to return here have the skills to come back and do the work that we're doing. And then also documenting and sharing how climate change is impacting the region and traditional food harvest. So a couple of, and this is both with a couple of audiences in mind, thinking about sharing and passing this knowledge on to the next generation, but also documenting and sharing this knowledge with people to help express how how difficult how the climate situation is impacting us in the region, and also to inform research and management about how this is impacting lives and livelihoods. So there's a couple of different mediums that were suggested that we could share the stories with. So documenting local observations of change through things such as the Local Environmental Observers Network and existing traditional knowledge databases, but also working with elders and youth to develop new media that shares traditional knowledge and observations of change, such as videos, books, and workshops. Number 3, increasing local capacity to mitigate and respond to climate impacts. Some of the actions that support this strategy, including providing education and technical assistance for tribes to incorporate climate change into strategic planning and daily operations. So that's developing tools to convey information about historic and projected climate conditions, much like Claudine was talking about. We think this will be really useful for these planning efforts. Reviewing and updating or establishing strategic planning documents, things like coastal flood risk maps, hazard mitigation plans, and community strategic plans. I know in the case of the hazard mitigation plans, there is currently an effort by FEMA, the Federal Emergency Management Agency that operates that program, to update some of the standards for the tribal hazard mitigation plans, and they'll have new updated standards in 2025. And these are, these plans can trigger opportunities or funding opportunities, and so that's why they can be very important for our communities. Also, conducting greenhouse gas emission inventories to identify local carbon sources and sinks. CERC is currently working with Native Village of Eyak on a pilot project for establishing some protocols for doing this and identifying low-hanging fruit in our region for carbon mitigation. And also conducting a First Nations Development Institute food sovereignty assessment to understand where and how we can help build up food sovereignty in our communities. Let's see, and then also identify funding and training opportunities to help tribal governments build capacity for addressing climate impacts. I know personally, there's so much funding that's out there right now, and not a lot of personnel to do the work, and to there's a lot of funding for implementation and not a lot of funding for jobs, and not a lot of training opportunities necessarily. And so really helping to build up human capacity within our tribes, as well as through things like providing training on climate change adaptation processes, grant writing and science, and just getting funding to have a person that can work on these issues locally are really goals that we have. And we'd like to move forward on. Let's see. Oops, I think I don't know why that was there twice. So continuing with that same strategy, we also want to develop localized downscale data for population management and document changes to habitat and subsistence foods that can be used to inform wildlife management and policy. Some needs that we've identified include getting better estimates for populations of things like marine mammals, crabs, and other species that kind of at the management level tend to be documented in or monitored in aggregate. And based on feedback from harvesters and fishermen, it seems like some of these populations might be doing different things than what is being documented, just because of when research is being done, and keeping some of the keeping the kind of the methodology similar across time. So we'd like to start doing some of our own population estimates and research to help inform management decisions. Also, we mentioned, or Jacqueline mentioned habitat mapping. So we'd like to do that for important subsistence species in the marine environment. Also working with modelers to understand how local biomes might shift over time and map potential habitat refugia, kind of based on where we changes that we can see coming or think might be coming. And also finally working with community members to document observed climate and environmental phenomenon, which can be used to, as I mentioned before, inform research need and management policies. Number 4 here, I'm going to skip over. I'm not going to go into detail on, but it's implement programs and projects that protect traditional foods and the ecosystems upon which they depend. I do actually have several slides about this, but this is kind of the meat of this. And so I'm going to skip on and we'll come back to it. And then number 5, the final kind of action under this strategy is become leaders in kelp mariculture research and production to provide jobs, food, and ecosystem benefits to the region. And then our last strategy that we had was taking action to promote human and community health and safety in a changing environment. We identified 3 kind of focuses for this so far. One is reducing risk to human health from wildfires, which includes both wildfire prevention, what we can do for that to keep our community safe, but also air quality and providing clean opportunities or refuge with clean air for people and communities when there are fires. Developing additional drinking water sources and storage for the southern, for our communities on the southern Kenai Peninsula. That area is really drying up, and a couple of our communities have already been having water shortages. And so this is a really high priority to identify long-term sustainable solutions and water sources for Port Graham and Nanwalek. And then finally, understanding the links between climate change, erosion, landslides, and tsunamis. And we've been working with researchers to understand some of the increased risk for tsunamis from instabilities like the one that was discovered up near Whittier. I'm totally blank, Barry Arm, apologies. I blanked on the name for a second. The Barry Arm slope instability, and identifying other places like that that are high risk areas and developing a monitoring and communication system to make sure that people are safe while they're out on the water. And then, as I mentioned, kind of our last strategy is just to come back and periodically review and update this plan so that it reflects our current needs and priorities. So there's only about 10 minutes left. What I thought I'd do is maybe pause here for some questions, if anybody has any or thoughts or suggestions. And then I also have, as I mentioned, some of the specific strategies for different species that we've identified. And if there's ones that people are most curious about for the sake of time, I'd be happy to kind of flip through those and talk about those a little bit more in depth. But like I said, I will pause first for any questions, comments, feedback, anything like that. Okay, not hearing any questions or comments, and I realize I talked a lot and this is a lot of writing. Again, I apologize. I will.
Karen, we just got a question from Bjorn.
Oh, okay. Oh, I can't really, there we go. There's my chat.
The topic of rewinding or maybe rewilding ever considered, such as reintroduction of beavers to restore wetlands?
Yes, actually, that was one of the, I believe it's in our salmon strategies, but that is one of the things that came up and is under consideration. I think that there's a lot of interest in that, particularly on the Kenai Peninsula, on the western side of the Kenai Peninsula and our southern Kenai communities. And also, you know, a lot of some of our on the road system communities too, some of the recommendations we have are for rewilding, restoration, making, you know, going back and checking on culverts. There's a lot of, I know, well, it says right here in this, what I'm sharing with you, that Port Graham and Wallick, the last culvert assessment, at least according to the database I found, was 2004. And then there was a lot of culverts that were reported in bad shape. And so, I think that there's a lot of work that we could be done that's kind of low-hanging fruit there with rewilding and making sure that we protect salmon streams. So the way that we worked and designed kind of these species-specific recommendations was through the workshops. We documented and talked about some of the observed impacts that people had noticed, and did some brainstorming around potential activities and actions that we could take to address those impacts. And then I've been supplementing those discussions and that work with research about what's happened elsewhere and what's been successful elsewhere. Bjorn asked about the beaver dams or reintroducing beavers, and that was something that we considered as a pilot project for combating or warming temperatures in streams and creating more habitat for salmon. We also had a lot of kind of pilot projects looking at how successful are these potential, or how well do these work? What are the co-benefits of a lot of different activities? Thanks, Kat. So things like understanding all the co-benefits of kelp farming. For example, we've got it here looking at, can it help reduce straying or help with salmon populations returning to their native streams? There's some evidence that it might help with that. But also, we have questions about what are the co-benefits of kelp gardens on copepod survival and kind of food web dynamics. Are you getting those kind of, can we quantify the co-benefits to understand a little bit better what this one activity that we're doing to say make money on kelp, but we can also identify other opportunities to protect our environment. So that was, I realize I'm not kind of going into depth because this is just a lot of reading, but if anybody has any questions about any in particular, I'm happy to stop, and I will maybe do a couple of highlights over the next minute or two of some of the other resources. So let's see, that was salmon. Halibut came up as well. Halibut, there was a lot of concern about the food web, and a lot of the solutions came down to identifying and monitoring sources of malnutrition and disease, and also supporting prey fish for halibut. Forage fish, came up often about concern in regards to concerns about cascading food web impacts, and so there's a lot of opportunities for research to understand, kind of how those food web impacts are affecting our subsistence foods, but also identifying ways that we can support forage fish, especially past early vulnerable stages. Shellfish are huge in our region, and there's a lot of concerns, both about how climate change is impacting the shellfish directly, but also about contaminants and concerns about harmful algal blooms, and what it means to, are people going to be able to pass down these traditions, or are we going to have to stop eating these foods because of safety? And so a lot of the actions around shellfish involve understanding their life cycles better, supporting the growth and development of young vulnerable stages, so that through things like clam outplanting and clam gardens, and also developing testing and warning systems for food health and safety. marine mammals. There's a lot of, again, a lot of concern about food web impacts to marine mammals. And so some of the work that CERC has already started doing and a lot of the recommendations have to do around understanding how diets are shifting, or monitoring and understanding how diets might be shifting as a result of climate change, and monitoring the health of the resources. And also supporting the continuity of the culture of marine mammal harvest. Things like developing butchering facilities at docks for harvesters to use, and providing education opportunities for people to learn how to harvest these resources. Land animals, there's a lot of there was a lot of concerns about reducing habitat, being able to find food forage in winter with more snowfall for moose, and reducing habitat for mountain goats. And so in those cases, it was, again, a lot of the recommended actions were partnering with wildlife managers to monitor how these resources are doing, particularly populations that our tribes depend upon, and also mapping potential habitat refugia for these resources. And then Sitka deer are actually increasing in numbers and moving onto the Kenai Peninsula. So there's a lot of questions about, can we, or what would ecological implications of that be? And actually, can we help maybe, or can we support that movement to replace moose and mountain goat populations that might not be as accessible? So that is that's the end of my presentation about this draft adaptation plan. As I mentioned, I welcome a lot of feedback, and I will be completing this by the end of the month, and looking for feedback over the months of December and January. So if you would like to review the full draft and provide comments and feedback, please please just send me your email or fill out that Google form that will give me your email, and I will be happy to send that to you. Are there any final questions, thoughts? Oh, thank you, Bjorn. And thanks to everybody that helped contribute to this work as well, especially the climate cohort that and Gwen, who has spent a year with me helping to brainstorm and figure out all of these challenges. Great. Well, thank you all very much for joining us today. Our next webinar will be at 11 a.m. on the 3rd Thursday of January. We are actually skipping December. And I am trying to get my calendar to come up so I can see what that date is, but I believe it's January 17th or 18th. And we'll be talking about mariculture and ocean chemistry, or mariculture and harmful algal blooms in that webinar. So we're hoping you'll be able to join us. I'll be sending out a flyer with more information and a registration link over the next month or so. So thank you all very much, and have a wonderful afternoon.
Thank you, Erin and Gwen.
Thanks, Erin, Gwen. Bye, everyone.
Bye-bye.